This is a video covering rational functions. In the previous lesson, we looked at real-world situations that might use a rational function, and now we're going to look at all the features and attributes of these functions. The learning target for this lesson is I will be able to identify features of and transform rational functions, including horizontal asymptote, vertical asymptote, reflection over the x-axis, vertical stretch and compression, horizontal shift, and vertical shift. I need to know how to graph in Desmos and how to compare two rational functions. I also need to know what the variables in the general equation are. I will show that I can do this through independent practice to 80% accuracy. So let's take a look at rational functions. If you look here, the general equation for rational functions is y equals plus or minus. Remember, the plus or minus will tell you if there's going to be a reflection. If you have a negative in front, it means it's reflected over the x-axis. A over x minus h. Remember, the a value tells us if we have a vertical stretch or compression, and the h value tells us if we have a shift left or right. And then plus k, the k tells us if we have a vertical shift up or down. The domain and range for a rational function is always all real numbers except where the value is equal to the asymptote. Now, in a rational function, we have a horizontal asymptote, which if you look here on this picture, it's here. And that is the line that the graph approaches but never touches. Horizontally, that line is where y equals 2. And so this is y equals k. And whatever the k value is, that tells us what our asymptote is. Now the vertical asymptote is here in this example, and it is where the graph approaches but never touches the certain x value. And this is where x equals h, and in this case, it's x equals 2. Of course, we know our y-intercept is where our graph touches the y-axis, and our x-intercept is where the graph touches the x-axis. In this case, it's about right here for the y-intercept. And for our x-intercept, we don't have one because, as you can see, this graph will never go below positive 2. Example 1 says, describe the transformations for the graph. F of x equals 7 over x minus 6 plus 5. So what we're going to do here is we're going to first look to see if we have a reflection. In order to know if we have a reflection or not, we look to see if there is a negative in the front of our graph. If there is, it's been reflected. Since we don't have one, we know there's no reflection. Then we look for our a value. In this case, the a value is 7. And because the a value is 7, we know we have a vertical stretch. So a vertical stretch by a factor of 7. Next, we're going to look for a horizontal shift. That's our h value. In this case, h would be 6. Notice that minus is a part of the formula. So h is actually positive 6. So we know we have a horizontal shift to the left because to the right, because we have that minus there of 6 units. To the right, 6 units. The last thing we're going to look for is a vertical shift. So we look for our k value, and in this case, k is plus 5. Since k is plus 5, then we know we have a vertical shift up 5 units. And that covers all the transformations represented by this function. Next, we will identify different features for the graph of y equals 4 over x minus 1 minus 4. So first thing we'll do is look for our x and our y-intercept. And our y-intercept is always going to be where the graph touches the y-axis. And here we can see it's where y is negative 8. So we know our y-intercept is 0, negative 8. Now our x-intercept is where the graph touches the x-axis, so that would be here where x is 2, so our x-intercept is 2, 0. Our horizontal asymptote is the line that our graph approaches but never touches. So here we can see that our line, our graph, approaches but never touches 1 vertically, and looks like 4 horizontally. So let's write that out. Our horizontal asymptote would be where y equals k, which is negative 4, so y equals negative 4. Our vertical asymptote would be where x equals 1. Now when we look for domain and range, we know our graph will go on and on forever in both directions based on the curve. However, it will never equal whatever the value of the asymptote is. So for our domain, it's all real numbers except where x is equal to 1. When we write it as all real numbers, x does not equal 1. For the range, it's pretty much the same thing. It's going to be all real numbers except where y is equal to our horizontal asymptote, which is at negative 4. So y cannot equal negative 4. Take a look at the next example. Identify each feature of the graph for y equals 3 over x minus 6 minus 3. I went ahead and graphed this equation in Desmos, and I would like for you to pause the video here and go ahead and answer each of these questions. And once you are done, then you can check and see how you did. Now compare your answers to the answers you see here. How did you do? Hopefully you were able to understand and complete each of the different attributes. So in today's lesson, you learned how to identify features of and transform rational functions, including the horizontal asymptote, vertical asymptote, reflection of the x-axis, vertical stretch and compression, horizontal shift, and vertical shift. And now it's time for you to practice and show what you learned. Thanks for watching.